Today I will be explaining to you the insert algorithm of a binary search tree. This algorithm is non-recursive in nature, and when we call the insert algorithm with the root node of the tree and the number that we want to insert in the tree. Now, in the algorithm, as you can see, we have taken a new node variable. This new node variable is not unknown to you. This new node is a pointer type variable of the node type, and this new node would be used to allocate memory for the new node that we are going to create. Then there is a parent node. As we go through the algorithm, the use of this parent node will be clear to you. And there is a P. Now, as we had learned in our linked list classes that we cannot lose the head node of a linked list, similarly in case of a tree we cannot lose the root node of the tree. So when we are traversing through the tree, we would be using this P pointer rather than using the root node of the tree. So that is the reason over here we have said P is equals to root. Now let me dry run this algorithm. Let me create a binary tree from the scratch using these 5 nodes. We are going to create the binary tree from the scratch. So therefore at the very beginning, the insert function will be called using null, because over here we will be sending the root value, and for an empty tree the root value is null. So the insert algorithm will be called using null, and we are going to insert the first node, that is 20. Right? Now as the insert algorithm is called, P is equals to root, so P becomes null. So over here P becomes null. Right? Now, while P not equals to null, but P value is null over here. So since P value is null, that is why P not equals to null becomes false, and this while loop does not run not even once. So we straight away come to this line. What is this line doing? This line, you are very familiar with this line. Using this line, we are allocating memory for a node. So as we execute this line, a memory is allocated, a node of bin tree type is getting created, which has got 3 parts. One is the data part that stores the data. This side stores the address of the left subtree, and this stores the address of the right subtree. So we have allocated memory, and new node data is equals to num. So we have stored in the data part, we have stored 20. Now when a new node is getting created, whenever a new node is getting created, let us do something. Let us do a small exercise. Let us create the tree over here first. Now, when we are creating this tree, you see, first we just put 20. And as we put 20 in the tree, the left and the right subtree of the 20 node is null. Next we put 15. Now since 15 is lesser than 20, it will come on the left hand side, and as we put 15 on the left hand side of 20, now the left and the right subtree of 15 is null. So in other words, you can say that the left and the right child of a newly inserted node is always null. So similarly over here, when we are creating a node and we are putting the data in the node, that the left and the right child or address of the left and right child of the node will be null, because a newly node always have left and the right child as null. So the left side will be null and the right side will be null. Right? Now if root double equal to null. Now if root double equal to null, this check is made for the for a node which is the first node of the tree. If the tree is initially totally empty, then this is the check that will be true. As you can see, right now our root value was null, as when we called the function the root value was null. So for us, this if condition will become true and the new node will become the root node. So this new node that we had or that we created right now became the root node of the tree, and we have inserted the first node of the tree. Now coming to the next one, we want to insert 15. So when we want to insert 15 in the tree, then insert will be called using the root node, that is 20, and 15 is the value that we want to insert. Now the main idea of this algorithm is first to find out where the node will get inserted. That means we have to find out a node which will become the parent of the newly inserted node. For example, in this case, when we were inserting 15, 20 became the parent of the node and 15 got inserted on the left hand side of 20. So whenever we are trying to insert a node in a binary search tree, we have to find out the parent node which will have the newly inserted node as the left child or the right child depending on its value. I will repeat again. The main idea of the insert algorithm is to find out the parent node which will have the newly inserted node as its left or the right child. So therefore we will start from the very beginning. P is equals to root. So this node becomes our P. Now while P not equals to null. Now at this moment, if this becomes our P node, P is not equals to null, that is true. So we enter the loop. If P data is greater than num. Over here, what is P data? P data is 20. P data greater than num. What is our num value? Num value is 15. So 20 greater than 15 is true. So it will enter this if condition, parent equal to P. So this node that was getting pointed by P will become the parent node, and P is equals to P left. Why P is equals to P left? Because P data is greater than num. So this num cannot exist on the right hand side of P data. It has to be on the left hand side because num is lesser than P data. So P is equals to P left. Now as we go to P left, over here we see P left is null. So currently my P value becomes null. Correct? Now again when we again go back to the while loop, P not equals to null becomes false. Correct? So we come out of the while condition. Again we are creating a new node over here. So we allocate memory for a new node and we insert 15 as the data value. And as we have already discussed, a newly inserted node always has the left and the right child as null. So we will have null and null over here. Right? So these 4 steps are done. Now we have to insert this 15 at the correct location in the tree. So where will 15 get inserted? 15 will get inserted on the left hand side of 20. Now if you see, 20 is getting pointed by the pointer parent, and this 15 is getting pointed by the pointer new node. So that means parent left will become new node. So let's see how we are doing that. if parent data is less than 15. So over here parent data is less than 15 is not true. So it will come to the else part, and in the else part it will do parent left equal to new node. So parent left will start pointing at the new node. So thus 15 gets inserted on the left hand side of 20. Correct? Let's do it for 30 again, and so we will be able to understand it better. Now when we call the insert function for 30, again it will be called using the root of the tree and the number, right? Now, so we start from the very beginning. Again you see in the algorithm p is equals to root. So p is pointing at the root, while p not equals to null. P is not equals to null, that is true. P data, if p data is greater than num, p data, that is 20, greater than num. What is the value of num now? Value of num is 30. So p data greater than num is false, so it will come to the else part. Parent is equals to p is equals to p right. So this becomes parent and we move to p right. Now what is p right? Now p right is nothing but null in this case, right? So when we go back to the while condition, p not equals to null becomes false. So we come out of the loop. Again over here we are creating a new node. So a new node gets created. Data part stores the value 30. Left and right both are made null. Correct? So this is the scenario. Now we have to put 30 on the right hand side of 20. If root double equals to null is false, it will come to the else if condition. If parent data is less than num, which is the parent? 20 is the parent. Parent data is less than num, right? Because parent data is 20 and it is less than num. So this else if condition is true. So what is happening inside this else if condition? Parent right is set to new node. So that means parent right, that means this address will be pointing to new node. Clear? Now come to 35. Again let us start the algorithm. I want to do 35 because it will give you a better understanding how the second level works. We are in the first level only, which is much easier. Let's go to the second level. Again p becomes the root, so this is the root node p. While p not equals to null, p is not equals to null, that is true. If p data is greater than num, what is the num value? Num value is 35. P data greater than num, that means 20 is greater than num, is false, right? So we will come to the else part. Parent is equals to p is equals to p right. So this becomes the parent and p is equals to p right. That means 20, this root node becomes the parent node and p is equals to p right, means this 30 becomes p, right? Now we go back while p not equals to num. Now when we were in the first level, in the second iteration of the loop, p was becoming null. But now you see p is pointing at 30 and p is not equal to null, it is true. So again we will enter the while loop. If p data is greater than num, now what is p data? P is pointing at this node 30. So p data is 30. So p data greater than num. Now what is p data? 30. Greater than num, that is 35, is false. 30 greater than 35 is false. So we will come to the else part. Parent is equals to p is equals to p right. So this becomes the parent node. This is no longer the parent node. This becomes the parent node and P is equals to P right. That means P becomes P right, that is null. Correct? Now when we go back, P not equals to null becomes false. So while loop ends, new node is created. So a new node gets created. 35 gets stored. Left and right child becomes null. Now, if root double equals to null is false because our root is not null. If parent data is less than num, so our parent data is 30 and it is less than 35, so it is true. So parent right is equals to new node. So using this right address part, we are pointing at the new node 35. Clear? So you see 30 got inserted on the right hand side of 20 and 35 got inserted on the right hand side of 30. So you see there are two paths to a insert algorithm in a binary search tree. First part is to find out which node will become the parent node of the newly created node, and the second part is to create the node and then attach the new node in the left or the right part or left or right subtree of the new, parent node depending on the value stored in the parent node. Right? So that is how the the insert algorithm works. So now it is your assignment to find out the recursive algorithm of this insertion. This is a non-recursive algorithm. So your homework will be to find out the recursive form of this algorithm.